Okay, so far you've had to like trust me when we call a vector A or B, and I've just said, okay, we could just describe, it's a movement. We're just going to call the movement from this thing to this thing. We'll call it B, we'll call it A. But actually we want to be able to give those vectors a lot more detail and actually describe what those pathways actually look like. And you should already be familiar with the value of a vector is the displacement in the x and y direction if we're talking in 2 dimensions. Later on when we go to year 13 vectors, we'll do 3 dimensions as well. So I'm hoping that you're familiar with some of these things from GCSE, that if we said that the vector A was 3 minus 2, we're actually describing that it's moving 3 in the x direction and minus 2 in the y direction, which works out as going 3 across to the right and 2 down because it's a negative 2. So this is actually the vector A as represented on graph paper. We're now giving some like numbers to these vectors rather than just leaving these vectors as letters that just represent pathways. We're actually going to give them some information. And for the vector B, if we saw the vector B as 0, minus 1, what does that actually look like if it's 0, minus 1? Just one down, okay? It's just one down. So I'm going to draw it somewhere else on the page. This is the vector here, which is B, which is just going one down. Now, it doesn't have to be there on the page. I don't mind where you draw it on the page, because remember, a vector doesn't have a fixed location. It's just describing a pathway that something is moving. And again, from GCSE, you can add these 2 vectors together by just doing this plus this, and it just behaves exactly how you'd expect it to behave. That 3 plus 0 is 3, and minus 2 add minus 1 is minus 3. But I wanted to show you what that would look like on our grid, because we still want to have the geometric understanding of what's happening rather than just the numerical understanding of what's happening here. When I add 2 vectors together, do you remember we had the triangle law of addition from that front page, where you draw the vectors following a pathway? So here is the vector A. I'm now going to take this vector B here. I'm going to move it so that I add it to the end of this one. And then the resultant vector, there's that language I've just used, the resultant vector, which means the vectors being added together, is just going to be, I'm going to use the straight line tool here so I don't make as much of a mess, from the starting point to the ending point. Let's draw that better. It's going to be this. This is the vector A plus B. And the vector A plus B is 3 minus 3. And you can see that this red line is going 3 across and 3 down. So hopefully it makes sense that to find out how much it's going across overall, you just look at the across bits and you add them. And then to find out how much it's moving up and down, you just look at those bits separately. Because they're perpendicular to each other, they don't interact with each other. We've then also got the vector 2a. Well, again, this is going to make sense. This is just a 2, which is a scalar. And we're going to be taking the vector 3 minus 2, and we're multiplying it by 2. This means you're multiplying both parts of this by 2, so that you get 6 minus 4. And I'm going to draw 6 minus 4 on the board as well. Not sure quite where I'll fit it in. Let's see if it might fit here. So I'm going to go 6 across. 1, 2, 3, 4, 5, 6 across. Whoops, I haven't done that in the right place at all. 1, 2, 3, 4, 5, 6 across, and 1, 2, 3, 4 down like this. Hopefully we can see this vector is the same as this vector for A, but it's twice as long and it's going in the same direction. It must be going in the same direction because it's the same gradient, it's the same, it's multiples of the other one. So all of those reasons that we have of it, we've looked at so far, are going to just show that to us, okay? I wouldn't draw that one in because we might need to use this in just a second. Now this is where there's something that I think this is new. I don't think you look at I and J stuff in GCSE. What we tend to say at GCSE is, oh, you go 3 in the x direction and minus 2 in the y direction. And we've just got a new way of describing that at A level. And the way we describe this is to do with I and J. So it says here that a unit vector is a vector of magnitude 1. What does magnitude mean? Size, length, okay? So the I and J are unit vectors in the x-axis and y-axis respectively. Now, they are just vectors that are not to be confused with like A, B, and C, like we were using earlier. If we write the vector I underlined or the vector j underlined, that is the language that we start using instead of x and y with vectors. We don't use x and y with vectors. We describe their movements in terms of the I unit vector and the j unit vector. The I unit vector is just one movement to the right and no movement up or down. It's just what we use to describe that component piece of moving one position to the right. We use the letter I for that. And the letter J is 0 in the left and right direction, and it's 1 in the up direction. The way I remember that I goes with X and J goes with Y is because of the alphabet, because I comes before J in the alphabet and X comes before Y. And if you don't like that way of remembering it, J makes me think of like jump, and so jump is going upwards. Okay, it's just a couple of ways of remembering the differences between these things. So the vector 4, 3, which means go 4 to the right and 3 down, I could break that down as go 4 lots of one space to the right plus 3 lots of the space going up. So that is 4 times I plus 3j. So it's really just trying to say something that's pretty obvious here, that this column vector, which is 4, 3, can be written as 4i plus 3j. So I could actually go back up to these ones up top, and I could say, well, the vector A, what would this vector A be in terms of I and j? 3i. 3i minus 2. Does it say it down here? It's the same, it's a different one, actually. So we've got 3i minus 2j. People get confused about what these actually mean. All they're saying is you're going 3 spaces to the right and 2 spaces down. It's just expressing it in a different way. I is x-axis, j is y-axis. And they represent one movement in that direction. That's why they're underlined, because they actually are vectors that are telling you how to move. So we've got 3 vectors here. And we first of all want to write A in vector form. And then we want to write B in ij form. When I say vector form, sometimes I mean like column vector form. So for number 1, A is just going to be equal to 3, 0. Simple, okay? Question 2, B plus 2C in ij form. Now, my preference is to change them. Actually, no, we'll add them like this, okay? And then we can put them afterwards in a different form. So we've got B plus 2C. We have I plus j for B. Plus 2 lots of I minus 2j. So that is I plus j plus 2i minus 4j, which is I plus 2i is 3i, and j minus 4j is minus 3j. That is pretty much going to be the first and last time we will do calculations like this, because I hate doing calculations writing I and j, just because visually I find it really confusing looking at I and j. I think they look so similar to each other. My personal preference of how I would work out this one is I would say, okay, well, B is clearly 1, 1 as a column vector, and C is clearly 1 minus 2. So for me, an easier way of doing B plus 2C would be B plus 2C, like this. And it's much quicker to see you've got 1 plus 2 times 1, which is 3. And 1 plus 2 times minus 2, which is 1 minus 4, which is minus 3. Personally, I think that's a lot easier because you keep all of the I parts at the top, all of the j parts at the bottom, and they never get mixed and muddled up with each other. Whereas when we write it out in a long line like this, our brain looks at i's and j's, and then they start looking kind of similar because they're aligned with a dot, okay? So if there is a choice, I will always choose to use column vectors, even if they're asking for it in I and j form, because I can put it back into I and j form at the end. Column vectors are a much more efficient way of doing all of these calculations that we have here, okay? So we're going to now have a look at doing some trickier things with parallel. I'm going to do 2 questions here, and then you're going to try a couple of questions afterwards. So we have now been told we have got that C is equal to 3i plus 4j, and D is equal to I minus 2j. And we're going to answer question A and C, and then you're going to do question B and D. You won't be able to fit B and D on the page, so you'll have to do it on some separate booklet, okay? We want to find out what lambda is if C plus lambda D is parallel to I plus j. There's a lot more going on in this question, so make sure that your concentration is turned up fully here. First of all, I'm going to write down, I want to do everything in column vector form. So C is 3, 4, and D is 1 minus 2. And I'm going to try and translate this sentence that is here. I'm going to try and translate this sentence into a mathematical sentence. Yes?
Is this still talking about the last question? As in,
No, this is now a new question. This is talking about new vectors. It's talking about C and D. So it's talking about like new vectors, okay?
I know if it's 1, 1.
It doesn't say that it's 1, 1. It says that find out what lambda is. If C plus lambda D, remember lambda is just a number, is parallel to 1, 1. It's just, they're telling us if we add these two vectors together where the second one has been multiplied by lambda, we want it to be parallel to I plus j, okay? So I'm going to actually try and take this sentence. If C plus lambda D is parallel to 1, 1, how did we show that two things were parallel earlier on? Yep. You say that one of them is like a factor of the other one, or one of them is a multiple of the other one. So that's really important. We are going to say that this thing, we think, is a multiple of 1, 1. I've used k just because k is often used as a letter that is just a constant, okay? You can use many letters, but I've just decided to go with k. And so I'm going to write what this actually means underneath, because this is, people last year found this difficult. So I'm saying that this is parallel to I plus j. If you didn't have the k in there, what would I actually be saying? That they're equal to each other. That they are not just parallel, that they have the same direction and the same length. But I don't want them to have the same length. I just want them to be parallel to each other. This is going to be like such a small thing right now, but this will come up many times in year 12. This will come up many times in year 13. This will come up in mechanics several times as well. So if you are not sure what's going on by the end of these examples, you better get sure with it, because this is an important part of vectors. It will come up again and again and again and again. So I've written the sentence. As soon as I've written the sentence, the rest of the question is going to become a lot easier, okay? So I'm going to do C, which is 3, 4, plus lambda multiplied by 1 minus 2, and that's going to be equal to k times 1, 1, like this. And I'm going to use this to try and find out what lambda is equal to. So I'm going to see if I can write this vector as one single thing. This top part is going to be a 3 plus lambda times 1. And 3 plus lambda times 1 is just 3 plus lambda. What would the bottom part be?
-2.
4 minus 2 lambda. And that is going to be equal to k. Now, what do you think you could tell me about this? What do you think you could say about the top part or the bottom part? Can you deal with them separately? Yeah, we dealt with them separately before, right? So this is going to tell me a couple of things. It's telling me that 3 plus lambda is equal to k. And it's telling me that the bottom part, which is 4 minus 2 lambda, is equal to k.
You make a simultaneous equation?
It is a simultaneous equation, yeah. So what should I do? What's the best way of saying that? What's the best way of finding out what lambda is? Substitution. I can actually just say 3 plus lambda must be equal to 4 minus 2 lambda, because they're both equal to the same thing. And the reason they're equal to the same thing is because I and j are the same thing here, okay? So we're going to get that 3 plus lambda must be equal to 4 minus 2 lambda. So we end up with 3 lambda equals 1, and so lambda is a third. Now let's just actually go back to the question. You don't need to write this bit down because I'm going to run out of space. Let's go back to what this question was. That's, where is the question? Let's go back to this bit with the numbers, and we're actually going to put in when lambda is a third, and we're going to actually see what it is, and you're going to see why it's parallel. So don't write this bit down unless you've got some spare space, because we're going to run out of space. So if lambda was equal to a third, we would have had C, which is 3, 4, plus a third of 1 minus 2. So that would be 3, 4 plus 1/3 minus 2/3. 3 plus a third. I don't mind if you want to use a calculator. What is 3 plus a third? No, it's not 1 plus a third. It's 3 plus a third. It's 10 over 3. And what is going to be 4 minus 2/3? It's 10 over 3. Again, you could use a calculator to check this. Is this parallel to 1, 1? It is parallel to 1, 1. It is parallel to 1, 1 because it's 1, 1 multiplied by 10 over 3.
So isn't it minus or minus
4 minus 2/3 is 10/3 because 4 is 12/3. So 12/3 take away 2/3 is 10/3. So when when lambda is a third, we have made it so that those vectors are going 10/3 to the right and 10/3 up, which is parallel to 1, 1. Can anyone tell me anything more about this C plus lambda D when we make lambda a third? Can you tell me anything about, we know it's direction because it's parallel. What else do we know?
direction is the same?
The direction is the same, yeah. Do we know anything about its length in comparison to 1, 1?
It's a third of I and J.
It's not a third of I and J, no.
3 times?
The clue is over here. How much longer is it? It's 10/3 the length of 1, 1. Because it's parallel to 1, 1 because it's a multiple of it, but it's also been multiplied by 10/3. So 10/3 is like 3.333. So however long this one is 3.33 times longer than it. Okay?
So,
Yeah.
you know when you did the K, 1, 1?
Yeah.
So basically 1, 1 is I and plus J. So why is the K there?
The K is there is because it's parallel. It is a multiple of it. K could be any number at all. If you were to solve this simultaneous equation, the other value you get for K is 10/3. If you didn't have the K here, we would be answering a different question. We would be saying, when is this thing this vector? But the word parallel means that it is a multiple of it. Because do you remember earlier on, right back on the first slide that we had, we said that they are parallel when you can multiply them by a scalar. Yeah, and that same thing that we did down there, okay?
So you know, how do you get to 3 lambda there at the bottom? Where it says 3 plus lambda equals 4 minus 2 lambda.
Because they're both equal to K,
Yeah.
Simultaneous equation.
then if this is equal to K and this is equal to K, surely those things must be equal to each other because they're equal to the same thing. And you also didn't need to, if you didn't need to use this K, we can also see if it's parallel to 1, 1, then the top part must be equal to the bottom part for it to be parallel. So I'm going to do another example of this, and then the next part of the lesson is going to be you trying
You
this.
get just 3 lambda equals 1.
Oh, because I added the minus 2 lambda to this side to get 3 lambda, and I did 4 take away 3 to get 1. As I just did that last bit of solving the equation, okay? So I'm going to do one more of these questions, and then you're going to try 2 in your book, and you're going to try this one down here as well. So this next one that I'm going to do is going to be question C, and it wants me to find out what S is if C minus SD is parallel to 2, 1. So I'm just going to write that sentence out properly now in maths. So I want C minus SD, my mistake, C minus SD is parallel to 2, 1. What am I going to say for is parallel to? K. So I've changed that sentence that they've written here. I've translated it into a mathematical sentence. Now that I have a mathematical sentence, I'm just going to be able to start solving what's happening. So C is 3, 4. I hate the fact they've used the letter S because it looks like a 5. So just make sure that your S looks like an S and not like a 5. So if you want to, you could change this to a T when you're doing the calculation. If you don't like S, do it with a different letter. but I've started with S now, so I'm going to continue. And D is 1 minus 2, and that's going to be equal to, well, I'm just going to start multiplying this. I've got 2k and k. So the top part, what would the top part be? It's going to be 3 minus s, because you've got 3 minus s times 1. What would the bottom part be, Lily? 4 plus 2s, because you've got a negative times a negative, so it would be 4 plus 2s. Yeah, it's an s, not a t, okay? And not a 5. And that is equal to 2k, k. Now, what this is really telling us is that the top part needs to be double the bottom part. But I'm going to just do it with simultaneous equations because that way everyone will be sure of it. If you can just spot that I need to make the top part twice the size of the bottom part because of this relationship, then that's fine. But we're going to look at it with simultaneous equations. So this tells me two things. It tells me from the top that 3 minus s is equal to 2k. And from the bottom part, from the j components, it tells me that 4 plus 2s must be equal to k. And then I've got simultaneous equations again. What should I do to solve these simultaneous equations? What technique?
Just times the bottom by 2.
And then make them equal to each other. So I can either times the bottom one by 2 and make them equal to each other, or I can do what Ikram suggested, which is substitution, because I can take this, which is k, and I can substitute it where k is. So if I were to do that, I'm going to do substitution. So I get that 3 minus s equals 2 times k. But we know from the bottom one that k is good, is 2 times 4 plus 2s, because k is 4 plus 2s. Now I have an equation that's just got s with it, so I'm going to solve it. And I get that 3 minus s equals 8 plus 4s. Remember, these are s's, not 5s. When I solve this equation, I'm going to add s to this side so that I get 5s. That's confusing, a 5 and an s right next to each other. And then I'm going to do 3 minus 8, which is minus 5. So what is s equal to? Minus 1, okay? Now s is equal to minus 1.
I have one question.
Yeah, which bit are you confused about?
How do you get the k is 2, 1?
Because the question says it is parallel to 2, 1. So you get where the 2, 1 comes from, right?
Yeah.
The k is because it's not telling me,
Okay, now they are.
it's not telling me they're equal to each other, it's telling me that they're multiples of each other.
So the free fall from.
Yeah. Now I'm just going to really quickly show you why this works. So if s was minus 1, if I go back to this question that I've got here and I substitute in, I would have 3, 4 minus 1 instead of s, 1 minus 2. So I'm just doing a substitution to check that it worked. So that's actually 3, 4 plus 1 times 1 minus 2, which gives you, what does this equal?
Minus 1 over 2.
So you've got 3 plus 1, which is 4, and 4 minus 2, which is 2. Is 4, 2 parallel to 2, 1?
Yeah.
Yeah, because it's a multiple of 2, 1. 4, 2 is going 4 across and 2 up. 2, 1 is going 2 across and 1 up. They are parallel to each other. Okay, it's hard. This was what people found really hard last year. So I have done those 2 examples for you. You are going to do these 2 examples, and you're going to have a go at this example down here. I'm just going to remind you of one thing before you do this. The word resultant. Who remembers what the resultant means when it says the resultant of A and B? Total. Add them together. So resultant means A plus B. So when it's talking about the resultant, you're going to add them. You're not going to deal with anything in that form. You're going to deal with everything in this form, okay? I don't want to see anybody writing I and J. I want to see everybody using column vectors for this, okay? Yeah.